All right, good morning, everybody. So just a reminder, you have a quiz tomorrow. So in Chernoff Hall at 10:30, you've got a written quiz. I guess hopefully you've all seen the sample quiz from last term already. It's a similar quiz this term, so the types of questions are similar, the length is similar. I guess that's all there is to say about the quiz. Anybody have any questions? It is written, so bring a pen or a pencil. Yes?
Assignment 3's been posted, but there's no inspections. Is anything?
No, so assignment 3 is coming out later this morning, I hope. But it will be available. The date has also been moved. The due date's been moved to next week, too. Yeah. Any other questions? All right, so we're talking about Javadoc. So your next assignment, you do have to fill in some Javadoc. So you have to document your code on the next assignment. And so the expectation is that you do it using Javadoc. So we were on this slide here. What are we talking about? Okay, so when every public feature of your class should contain a Javadoc comment. Right? So anything that's marked public should be documented because public features are visible to everybody else. So if you have a constructor that's public, it should have a Javadoc comment. Right? The comment should describe the purpose of the constructor. So the no argument constructor, for example, right? You should describe that you should describe what it does. Right? So when you write your comments for your constructors and methods, because these represent actions, the recommendation is that the first word of your comment should be a verb, in order that it reflects the fact that this thing is doing something, right? So it's taking some action. So that's normally a verb, right? So constructors, they always do the same thing, right? They all initialize. So initializes is always a good choice for a verb for your constructor. Right? So what does the no argument constructor do? It initializes the coordinates of the point to 0, 0. I don't remember if I've explained what this @code construct is to this group. So when inside braces, if you put an @code, that will format the text after the tag @code using a different style of font. So it'll use what's called a monospaced font or a typewriter style font as opposed to the proportional font that's used elsewhere. So when it renders this into HTML, that part there will stand out from the rest of your comment. Right? So let me just jump ahead to here. Right. So the comment for the no argument constructor, the first sentence of that comment appears in the summary section, and you can see here that the text 0, 0 inside of parentheses is formatted in a different type of font. Now you don't have to do this in this course, right? So no one's going to check to see that you actually do this. If you end up in a professional job where part of your responsibilities are commenting stuff, then you're going to have to learn more about how Javadoc works and how you format your comments. Okay, so this constructor has no arguments, right? Constructors never have a return value, so there's never a return tag. If you have parameters, though, you should document those with an @param tag. Right? So each parameter gets its own little description. Right? So for example, the second constructor, right, which initializes the elements of the point to x, y, right? The parameters x and y both have a comment here. Right? You don't specify what the type of the parameter is. Javadoc will do that automatically for you. So when the Javadoc tool runs, it will extract the fact that these are doubles, and it will put that into the documentation for you. You are supposed to put the name of the parameter here. Right? So that x goes there, that y goes there. Right? The documentation for the parameters goes after the description of the constructor. Right? So it's just the name of the parameters and then the text describing the parameters. You don't put in any symbols here, so there's no hyphen or colon, and I'll explain what I mean by that in a second. Right? Often you'll think, hey, the comments for these aren't very useful. Right? So I mean, this is just the x value of the point, that's just the y value of the point. Right? And so the temptation is to just leave them empty and let people guess at what they are. Don't do that, right? Even if the comment seems unnecessary, you should put it in. Right? So here's another example. Right? So this is the copy constructor. So the copy constructor initializes the coordinates of this point by copying the coordinates from another point. Right? And it has, because it has a parameter, it gets documented with a param tag here. Right? So when you go and look at the generated documentation, so in the summary part, you get the first sentence of each comment. Right? You don't get any information about what the parameters are. When you go to the detail section, that's where the documentation appears. So in the parameter parts here, notice that you have x and y, and there's a hyphen here. Right? You don't put that hyphen in the comment itself. Right? So there's no hyphen here, right? And there's no hyphen here or here. Right? The tool will automatically insert whatever it wants for the symbol here. Right? All right, so if you have a public method, well, you should document that as well. Right? So the public methods, they will potentially have return types. So you have to document the return types as well. Right? Document all the parameters with @param. Document the return value with @return. And so our method set, right, which sets the x and y coordinate to specified values. This really should say sets the x and y coordinate of this point to the specified values, but that's all right. Right? So our parameters, new x and new y, are documented here. Right? And now the return type is also documented here. Right? So what does it return? Well, it returns a reference to this point. And then when you generate the documentation, right, in the return section, right, you get the text that you had after the @param tag. If your constructor or method throws an exception, then you should document what type of exception might be thrown and when, under what conditions will it be thrown. So the tag here is @throws. Right? You might wonder why it's @throws and return is just return. And so the question is, it's not clear. Right? Right? So throws is pluralized, I guess, even though the keyword itself is not. So it's a bit strange that they chose @throws, but that's what they did. So when you document the exception that's thrown, the tag is @throws, it's followed by the type of the exception, and then the condition under which the exception is thrown. So this is the counter constructor that initializes the counter to a specified value. Right? If the value is negative, then it throws an illegal argument exception. And when you go to look at the documentation that's generated, there will be a section @throws. Right? The type of exception is here. The hyphen is inserted for you automatically. Right? So don't put it into your comment itself. Right? And then the text is placed after the exception type. So Javadoc, so the document that's generated by Javadoc is a web page. So it's written in HTML. And that means you're allowed to use some HTML in your Javadoc as well. And the problem is Javadoc's a very old tool, so it only understands a subset of HTML. One of the tags that it understands is the paragraph tag. So if you want multiple paragraphs in your documentation, you can't just insert a space into your comment. That won't actually generate a new paragraph. If you want a paragraph, you have to put in the P inside of angled brackets. Right, so this is the point2 method add that adds a vector to a point. So we haven't seen the vector2 class yet, but there is a vector2 class in your course code. Vector2 is just a class that represents a two-dimensional vector. So with the documentation for add, right, we've got the description here. Right? So adds a vector to this point, changing the coordinates to this point. Right? Notice again, verb. Right? We want a second paragraph, so we use the p tag, and then we place in extra documentation for this particular method. Right? So this particular method has this nice comment here that says use this method when you want to write something like p equals p plus v. And when you generate the documentation, you'll notice that a paragraph is inserted here. Right? So if you read the standard library documentation, it's not unusual to see methods or constructors where the documentation is quite long. Right? And there, often the documentation will be split into multiple paragraphs. Sometimes there'll be a list inside the documentation, so you can use lists. What else can you normally see? You can put in links as well if you want. But the syntax for that is, you have to use a particular syntax for that. Okay, so if you plan on writing Java code professionally, then you really ought to click on that link and read about how you really, and read about the recommendations for writing Javadoc comments. That's a surprisingly long document for how to, on the advice for writing Javadoc comments. Right? And you'll see very quickly that Javadoc can actually do a lot more than what we've described here. Right? So there's many, many, many tags that you can use to document all sorts of features document all sorts of features. Right? Okay, so that's all I want to say about Javadoc. It's, you'll find that when you start to write Javadoc on your own, it takes a long time to write good documentation. I think you'll also understand why programmers don't like writing documentation. It's hard to do, and it is a skill that you need to learn, but it can be tedious to do. Okay, so method preconditions. Preconditions and postconditions. It's often the case that you will write a method, and in order for the method to run correctly, there has to be one or more conditions that need to be true before the method runs. So for example, if you try to divide a point by some scalar value s, then it doesn't make sense if s is 0, right? Because you can't divide by 0. So a method precondition is a condition that the caller of the method, right? So this is important, right? It's the caller of the method must ensure is true immediately before they call the method, right? So in other words, the responsibility for meeting the precondition lies with the caller of the method, right? It's not the person writing the method who's responsible for making sure the precondition is true, right? It's whoever's using the method is responsible for ensuring that the precondition is true. So if a method has a precondition, then that precondition really needs to be documented in your Javadoc comment. So Javadoc has no dedicated tag for preconditions. And so normally what ends up happening is the preconditions are documented in the method description, or in the parameter description, or in the fact that the method throws an exception. Right? So for example, here's divide. Right? So divide takes a point and divides its coordinates by the value s. Right? So the documentation says divides this point by a scalar value, changing the coordinates of the point. Right? Under the param tag, right? The documentation reads the scalar value to divide this point by must not be equal to 0. Right? And so there's where we document the fact that you can't divide by 0. Okay, now, if the responsibility for meeting a precondition lies with the caller of the method, then the question is what do you do if you're implementing the method divide? Right? So it turns out, the rule is that you can do anything you want. Right? So whoever's implementing divide doesn't have to look at the value of s if they don't want to. Right? They've told you, right? Whoever wrote the method, who presumably also wrote the documentation, they told you it must not be equal, s must not be equal to 0. Right? So the implementer of divide is allowed to assume s is not equal to 0. So we can ignore that case and just go ahead and implement the method, like so. Right? It's pretty straightforward, right? You just take this x and divide it by s, and take this y and divide it by s. So that would be a perfectly valid implementation of divide. Now there's a problem with this though. So if you assume that the precondition is true, then what does the method do? Well, it runs with invalid inputs. Right? What happens when you do this? So if the method returns a value, it will probably end up returning the wrong value. If the method encounters an error, then it may end up throwing an exception. And notice that there's no exception documented here. Right? So in other words, the caller will get back, the caller may run into an unexpected exception of some kind. The method may not be able to do everything that it says it will do. Right? So up here, you can imagine that the documentation for a method is just a contract between the method and the caller. Right? So the method is promising to do something, right? As long as the caller meets some requirements here. Right? So if the caller doesn't meet these requirements, then it's possible that whatever the method promised it could do, it can't do. Right? So in other words, you'll see in a few moments that these are called postconditions. So the method won't be able to satisfy its postconditions. And then finally, so this method here is a non-static method. So it takes a point and then divides the coordinates of that point by this value s. So if you have a non-static method, then the method might end up putting the object that was used to call the method into an invalid state. Right? So in this case, if we divide by 0 here, one of two things can happen. Either the x and the y coordinate become positive or negative infinity, or you end up with not a number. So if the x or y coordinate is 0, then after dividing by 0, you end up with not a number. Right? And then if you try to use that point for something else, any other arithmetic operation is going to lead to not a number. Okay, so here's an example of using that method. So here we call divide, passing in 0. Right? The method doesn't actually check to see if the value 0 has been passed in, so it just runs. And in this case, because these aren't 0, we end up with a point whose coordinates are infinity and infinity. Okay, so what you really ought to do, if it's not too expensive, is to check the preconditions, right, and throw an exception to indicate that the precondition has not been satisfied. Right? So in other words, you really shouldn't run the method if it can't successfully do what it says it does. Right? Okay, so you've seen exceptions already in the course a little bit. So you've seen them on assignment 1 and assignment 2. We're going to talk a little bit more about exceptions here now. So the term exception is short for exceptional event. So what happens when a method runs, when an error occurs in a method or constructor? The method ends up making an object. Right? So the syntax for throwing an exception is throw new something. Right? The key word there, new, is telling you that there's an object being made. Right? The object that's being made has type illegal argument exception. Right? So the method creates an object, so it makes an exception object, and then it hands it off to the runtime system. So whatever that means. So what that means is, right, when you throw the exception, the method stops running here. Or the constructor in this, no, this is a method. So the method stops running here. Right? And now what happens is whoever called divide ends up receiving an illegal argument exception. Right? So if there was some other method that called divide, that other method now has an illegal argument exception. Right? If that method doesn't do anything about the exception, whoever called that method now gets an illegal, that method stops running. Whoever called that method now gets the illegal argument exception, and so on and so on and so on, until you get back to the main method. If the main method ends up with an illegal argument exception and it doesn't handle the exception, then the program stops. So that's what it means by hands it off to the runtime system. Right? The exception object contains information about the error. So if you've ever run into one of these and you've looked at the output in your console, right, you'll actually see that there's this sequence of events that led to this exception being thrown. Right? All of that information is recorded by the exception object. So creating an exception object and handing it to the runtime system is called throwing an exception. Right? And you've got lots of choices of exceptions to throw. So let me just quickly pop open a web browser. Okay, so here's the exception class in Java. If you look at what are called the direct known subclasses, there's actually more. The direct known subclasses, you'll see a huge list of exceptions that can be thrown. Right? The ones that we're most interested in are the ones called runtime exceptions. Right? And if you click on that, you'll see, again, another huge list of exceptions that can be thrown. And you'll see the ones that we've already used. Right? So there's illegal argument exception there. You might have seen a index out of bounds exception. Where to go? Index out of bounds. So that's the exception you get if you use an array and you pass in invalid index. There's a string index out of bounds exception. somewhere, I think. Where is index out of bounds? Okay. Right, you'll see there's an array index out of bounds exception. There's also a string index out of bounds exception. Right, and many, many, many other types of exceptions. Right, and so when you throw an exception, you have to choose. Well, you can choose between these, or you can make your own. Right, but we're not really ready to make our own yet. Right, so these are probably 3 of the most common ones you'll see in this course. Null pointer exception is the exception that you get if you try to use a reference and it's null. Right, so if you have a reference that's null, you call a method, you end up getting a null pointer exception. Okay, so throwing an exception causes the method to immediately stop running after the throws statement. Right? Well, that means any code in the method after the throw statement never runs. And so what that means is you should always check the arguments first and then throw an exception if required before you change the state of the object. Right? So if your method that you're writing actually modifies the state of the object, the first thing you should do is validate the inputs. If the inputs are not valid, you throw an exception right away. Only after you're sure that the method can run to completion should you actually change the state of the object. Right? Otherwise, you end up changing the state of the object partly, right? Partway through, then the exception gets thrown, and now your object's in some unknown state. So here, right, the first thing you should do is check is S 0, and if it is, throw the exception. Right? Then you can divide x and y by s. Right? What you should not do is take x and y, divide them by s, and then throw the exception. Right? Because that puts the object into the infinity state. Right? And then, only then does the caller realize that something wrong has happened. Right? So validate first, change the state after you're sure that you can actually run the method to completion. Okay, so if there's a precondition, it makes sense that there's also postconditions. So postconditions are conditions that the method must ensure is true immediately after the method finishes running. Right? So here, the responsibility for meeting the postconditions lies with the method itself. Right? If one or more of your postconditions are not true, then whoever implemented the method has done something wrong. Right? Okay, so if we go back to the idea of a method being a contract between the method and a caller, right? The preconditions are the conditions that the caller must satisfy. Right? The postconditions are the conditions that the method promises will be true. The postconditions describe what the method promises will happen after the method finishes running. Right? So this method promises to divide the point by a scalar value, changing the coordinates of the point, and it promises to return a reference to this point. Right? So both of those have to happen in order for this method to run successfully to completion. Okay, so what can postconditions involve? Right? So the postconditions for a method can involve the value returned by the method, if there is one. Right? So in other words, the method might promise to return something, right? And it's up to the method to ensure that that something is returned. It might involve the fields of the object. So divide is one such method. Right? So divide promises to change the x and y coordinate of that point. Right? So one of its postconditions is that x and y both change. Right? And then finally, a method might change one of the arguments passed to the method. Right? So for example, if you pass a list to a method, then that method might promise to clear the list or remove some element from the list or swap 2 elements in the list or something like that. Right? So a method can change the state of an object that's passed to it as well. Right? So the postconditions, there could be, a method might have many postconditions. Now where do you describe these? So there's no postcondition tag in Java. So normally these are described in the text of the documentation of the method. Right? So for example, the method x that returns the x coordinate of the point, well, that's its postcondition. Well, the postcondition involves returning the x condition, the x coordinate of the point. Okay, so Preconditions and postconditions are conditions, right? So there's something that evaluate to true or false. Right? So that means in order to express a postcondition or a precondition formally, right, you have to express it as though it were something that's true or false. Right? So if you look at this method here, you sort of stare at it and you say, well, what is the postcondition of this method, right? So how do I express the fact that it returns the x-coordinate of the point using some condition? And it turns out to be incredibly awkward. Right? So let's take a look at this. Right? Okay, so if I actually wanted to express the postcondition in Java, you would end up doing something like this. Right, so here's my method x. Remember, all it does is return the x-coordinate of the point. So I'm going to remember what the current x-coordinate is when the method is called. Right, so that's old x. I'm going to remember what the current y-coordinate is when the method is called. Right, I'm going to mark them final. So I know that old x and old y, I know that they really are this x and this y. Right? I can't change old x and old y anywhere else in the method. Right? My result is going to be this dot x, and it's also final. Right? So again, once I assign the value to result, I can't change it. Right? And now we return result. Right? Now the part, where you want to check the postcondition is after the return statement. Right? So a postcondition is something that has to be true immediately after the method returns. Right? So immediately after here, you want to check the postcondition, which you can't do in Java, right? Because the method stops running on that return statement. Right? But if you could, then the postcondition ends up being that. Right? So what's the postcondition mean? It says, well, this x equals old x, this y equals old y, and this x equals the result. Right? So why is all this stuff here? Right? So why is the this x equals old x here? So that's there to ensure that the method never changed the state of the object. Right? So the method, this method should not change the state of the point. Right? That's what this y equals old y is here for as well. Right? So those first two conditions state that the state of the object never changed. Right? The third condition states that the returned value actually is the x-coordinate of the point. Right? And so you have to do all of this work, right, in order to express the postcondition for what is arguably the simplest method that you can write. Right? And so notice it's actually very awkward to do. And you can't actually check it correctly because you can't check the postcondition here. Right. Yes?
When would you ever really use the final condition? Because I feel, wouldn't it just be easier to have like a set variable for something you never really get to touch?
Wouldn't it be easier to have a set variable for something you're never going to touch?
Yeah, because you said like once you set a variable to the final, you
Yep.
can't change it again.
Yep.
But when would you really do this?
When would
As
you?
opposed to just having a variable.
So when would you really do like this exactly?
No, well, I assume this is just a generic example of like how this would work. But when would you really use final?
When would you use final? Oh, so you use final when you want a value where you want to make sure it never changes. Right? So when you mark a value as final, it means you can only assign it a value once, right? So you would use final. So in this case, we're marking old x and old y final to make sure that whatever else we write, right? Imagine this was a long method, right? So whatever else we write in the method never actually changes old x or old y, right? So it's there to help you make sure that your code is correct. Right? Okay. So in Java, this is very awkward to do, right? Checking your post condition, even for a method that's as simple as this, right? So there are, yep, question.
One commenting, do we actually have to add post conditions?
No. Normally the post condition is actually here, right? So it's described in English up here, right? What that English statement implies is all of this nonsense here, right? That's what I'm saying, right? Now the question is so in Java this is hard to do, but there's other programming languages where all of this stuff is actually done, right? So there are programming languages where you can specify the preconditions to the method, right? Somehow, right? And in those languages, you can also specify what the postcondition is for the method. When you specify the postcondition, usually those languages have a facility to do this sort of stuff automatically. right? So in other words, these languages know, have the ability to know what the state of the object is when the method was called, right? So you don't have to manually do this yourself, right? And then these languages will automatically check the postcondition when the method stops running, right? So these particular types of languages are used in software engineering of mission critical languages, right? Languages that are used where the outcome of an incorrect result can be significant, right? So stuff like spacecraft or medical devices, hopefully the stuff in your car, but probably not, unfortunately, right? And things like that. Right? And so somewhere in, I don't know, third or fourth year, there will be a course where you learn about this sort of thing, right? So this falls into the area of software engineering called formal methods, right? Formal meaning mathematical, right? Because this is basically what we're doing here, right? We're basically describing the mathematical the behavior of this method mathematically. Right? If you can do that for an entire program, you can actually prove if your program is correct or not. Right? I think it's a fourth year course called Formal Methods. Right? Okay, so let's look at one more example, and then that'll be it. I don't want to beat this to death, right? Because you can't really, it's really awkward to do in Java. So this was for a simple little accessor method. What does it look like for a mutator method? Right? So in a mutator method, the method's going to promise to change the state of the object. Right? So there's one. Right? Here's the method x that changes the state, that changes the x coordinate of the point. Right? So how do you express the postcondition of this method? Right? So it's going to be something similar. Right? I'm going to remember what new x is. I'm going to store that as param x. Right? I'm going to remember what the current y coordinate is. So I'm going to store that as old y. I'm going to go ahead and change x, this x to new x. Right? And then I'm going to remember what the return value is. Right? And then finally, I can return the result. Right? So the postcondition for this method is this x equals param x. Right? So in other words, the x coordinate has changed to whatever new x was. Right? The y coordinate equals old y, so the y coordinate hasn't changed. And the return value is, in fact, the correct return value. Right? So why are these marked final? So why is new x, why do I copy new x into param x and mark it as final? Because here, you can actually change the value of new x. Right? So for example, whoever implemented the method, could have written new x equals 1. Or something like that. Right? Maybe they're testing their code and they temporarily injected that line of code just to see if it was working properly. Right? And then they forgot to take it out. If you forget to take it out, right, this method doesn't do what it promises to do anymore. Right? And now it sets the coordinate to 1 instead of setting it to new x. Right? So if you don't check that this x is in fact equal to the original value of new x, right, you can't be sure that the method actually did what it said it would do. So again, notice that even for a method that's as simple as changing the coordinate, changing one of the coordinates of the point, it becomes very awkward to specify the postcondition for the method formally. Oh, there's the example right there. There's where I changed. So there's where I actually changed new x inside the method, right? And now this method doesn't do what it promised to do. Yes.
Couldn't new x still change because you're not seeing this stuff?
It will. Yes, that's right. But the postcondition will catch the fact that new x changed, right? Because you're checking, is this x equal to the original value of new x here? Yeah. That's why the postcondition's there. Okay, so is there actually a way to check the postcondition? Well, you could use an if statement to check the postcondition and throw an exception, right? The problem is this imposes a cost on every caller of the method, right? So if you really wanted to, you really could check this. You could check the postcondition right here, right before the return statement. It doesn't guarantee that your method's correct because the return statement might do something funny, right? But it gets you part of the way there. Right? So how do you, if you actually wanted to do this, what could you do? Well, I could do this all the time, right? So in other words, check the postcondition all the time, right? Now, the problem with checking the postcondition is, right, you have to pay the cost of that check every time you call the method, right? which may not be appropriate when you release the final version of your code. Right? So in other words, when you release the final version of your program, you might not want to have to pay the cost of this if statement every time. Right? You can imagine that the postconditions might be very complicated for more complicated methods. So for example, imagine sorting a list, right? And try to write the postcondition for sorting a list and see what you come up with. Right? It's not cheap to check. Right? So you may not be able to afford the price of this check every time. Right? And so what can you do instead? So instead, there's this facility called assert in the language. So assert is a statement that has a condition that you think is true. Right? So if the condition is not true, then an error is thrown. So the nice thing about assertions is you can turn them on and off. Right? So in other words, you can tell the compiler to ignore all assertions, or you can tell the compiler to enforce all assertions. Right? So the idea is when you're developing your program and debugging it, or when you have to maintain and debug your program, you turn your assertions on. Right? And so that will help you catch any errors that you've made. Right? Once you are confident that your program is working correctly, you can turn assertions off, and that gets rid of the check. Right? So you no longer have to pay the price of checking the statement every time. Right? So the way you do that is with an assert statement. Right? So assert the postcondition. If the postcondition is false, assert will cause an error to be thrown. If the postcondition is true, then assert does nothing. Right? And so that's one way that you can check well, not just a postcondition. You can check anything this way. Right? So if there's some condition that you suspect has to be true, right, and you're debugging or trying to develop your program, you can always use an assert statement to help you. So if you want to use these, then in Eclipse, they're turned off by default. And you can turn them on following those steps there. Right? And then you can turn them off following a similar set of steps. OK, so we've got preconditions and postconditions. Right? So preconditions are things that must be true before the method is called. Right? Postconditions are things that must be true after the method finishes running. Are there other conditions that we have to enforce, or we might have to enforce? And the answer is yes. There's these things called class invariants. Right? So an invariant is a condition that is always true. Right? So what's a class invariant? So a class invariant is a condition that's always true regarding the state of an object. Right? So if the invariant involves the state of the object, then who's responsible for making sure that the invariant is true? Right? So the constructors are responsible for ensuring that the invariant is true because the constructors are the ones that initialize the state of the object. Right? Every public method is also responsible for ensuring that the invariants are true. Right? Okay, so some classes have no interesting invariants. Right? So point 2 has no interesting invariants, right? We don't really care about the x and y coordinates, right? They can have any value. So there's no interesting invariant on point 2. The counter class, though, does have an invariant, right? So remember, our counter promises that its value is never it's never negative, right? So in other words, the value of a counter is always greater than or equal to 0. Furthermore, it also promises that the value is less than or equal to integer max value. So that's the class invariant for the counter class. Right? Now every constructor has to make sure that those two conditions are true once the constructor finishes running. Every public method has to ensure that those two conditions are true after the method finishes running. Right? And so if you look at the counter class, do I have it here? Sure. So let's look at the counter class and see if those invariants are true. Right? Let's see. Okay, ignore the check invariant line here. Well, let's do it this way. So I'm going to insert this method called check invariant. Right? So my invariant just asserts that the invariant is true. Right? So this value is greater than or equal to 0. I don't have to check the second part. Right? Why don't I have to check the second part? Because value is an int, which means it can never be bigger than integer max value. right? So I don't have to explicitly check the second part of the invariant, right? So all I'm really concerned about in this case is checking that the value is always greater than or equal to 0, right? So that constructor here, right, sets the value to 0. When I check the invariant, it's true. Right? The second constructor, how does this ensure that the invariant is true? Well, it actually checks the incoming value. Right? If the incoming value is less than 0, it throws an exception. Right? Only if the incoming value is greater than or equal to 0 does it actually set the value. So when you check the invariant is also true. Right? The constructor that copies another counter, right, sets the value of the counter to the value of the other counter. Right? If all of the methods in the class are correct, then other value must be between 0 and integer max value. Right? In other words, that value there satisfies the class invariant. Right? So when I set the value of this counter to that value there, we know that the invariant must also be true. Okay, so for the value, it returns a value. I can't check the invariant after the return statement because you're not allowed to have any code after the return statement. So we have to check it right before the return statement. Right? Is the invariant true? Well, yes, assuming the rest of the class is true. Assuming the rest of the class is correct. Right? What about advance? Right? So how does advance ensure that the invariant is true? Right? It checks, is the value not integer max value? Right? If it is, it goes ahead and adds 1. So that's fine, right? So if the value is greater than or equal to 0, but not integer max value, then adding 1 to the value ensures that the value is positive, right? So the invariant is true. If the value is integer max value, then it sets the value to 0, right? So it wraps around, right? But again, the invariant is true, right? So that also satisfies the class invariant, right? And toString, right? All toString does is make a string that involves the value, but it doesn't change the value, right? So if all the other methods and constructors are correct, then the invariant is also satisfied here. Right? And so that's an example of a class that has a class invariant. Right? Not all classes have invariants, but many of them do. If a class has some invariants, then you have to pay careful attention to how your methods are implemented in order to make sure that the invariants are satisfied. Right? So remember, an invariant is something, it's a public feature of the class. Right? So it's something that the class promises will always be true. What does that mean? It means anybody who uses the class gets to assume that the invariant is in fact true, right? And they can write their code assuming that invariant is true. If your class is broken somehow and the invariant is able to become false, then everybody's code that's written using your class now breaks or potentially breaks, right? And that's a problem. Right? So later on, we're going to see, probably in a week or so, we're going to see a different example of a class that has an invariant, and you have to go through quite a bit of effort to make sure that the invariants can't be broken. Right? But for now, I think we're done for today. Okay, so just one more reminder, you do have a quiz tomorrow, right, in Chernoff Hall. Unless you have an academic accommodation, right, in which case you should have gotten an email from me, or you should have gotten a notice from Ventus about when you're writing, right?